Okay, this is just another quick momentum video. A couple people asked, so this is going to be hand-drawn and really bad, but that's okay. Alright, so let's just say we have a slope here, and let's say we have some kind of little car up here, like a little matchbox car or something. And this little matchbox car is going to come down here and hit this tennis ball or something. So let's say that the car, this distance from the car to the ball is, let's just say 1 meter. And let's say we want to know the mass of this ball. So we're doing something a little bit different than we've done previously. We've been finding the momentum of the ball and then finding the velocity of the second ball. So this time we're going to use the momentum of object 1 to find the mass of object 2. So we would have to know the forward velocity of this ball if that's the case. So I'm just going to make up a number here, and let's just say that this ball goes forward at 2 meters per second. Sorry, this is kind of messy. And then we would need to know, let's just say we already know the momentum of this car. So let's just say that it's given to you that the momentum of object 1 is, it doesn't want to do that little equal sign. The momentum of object 1, let's say, is 40. Let's just say 40 kilogram. It's really hard to draw a K like this. Kilogram meters per second. Okay. So this takes into account a couple of things. We could figure out the speed of this car if we had a per second time, so we could do 1 meter per second. We're given a per second here, so we could divide momentum out and figure out the velocity of the car. If we have the velocity of this car, we could also figure out the speed of this car. So what I'm actually going to do with this one is kind of go a little bit back and forth between the car information that we might want to find out and the mass information over here that we want to find out. So looking at this, if we have momentum of the car here, this momentum, our law of conservation of momentum, says that if this is a closed system, none of this 40 kilograms per meter per second is going to be lost. So all of this 40 kilogram per meter per second is going to be transferred to the little ball over here. And so then we can say that our momentum, so I'm just going to put this up at the top here, momentum is mass times velocity. So if we were going to try to calculate the mass of this little ball, we would say that this 40 kilogram meters per second that the car is going to hit that ball with is equal to whatever this mass is times this velocity. So at this point I'm going to save this drawing just so I can kind of type this stuff up underneath, and I think that might be a little bit easier for you guys to read, at least. So now for underneath here, and we have momentum of the ball is equal to 40 kilogram meters per second, and that's actually equal to the mass over here of ball 2 times this 2 meters per second. So times 2 meters per second. Okay, so now if we wanted to figure out the momentum, it's going to be that, sorry, that's going to confuse you guys. Okay, so if we take this 40 kilogram meters per second and we divide it both sides by these 2 meters per second, so I'm going to go this, divided by 2 meters per second. That's going to give me a kilogram unit, so meters per second divided by meters per second is just going to leave kilograms right here. And that is going to give me a mass, because kilograms is a mass. So 40 divided by 2 is 20 kilograms, and that would be the mass of this little ball. right here. So I'm going to edit this now to make this be 20. So we just found out that this is 20 kilograms. That's horrible. Just go with it. Okay. Ah! All right. So kilograms. Try that again. I think it got too close to the edge and it didn't like it. Kilograms. There we go. Okay, so now we can actually use what we have over here now, because now we have a complete momentum for the car and a complete momentum for the ball and a mass for the ball and a velocity for the ball. So if I want to find out how fast the car was going, I can actually do that. So let's just say that the car traveled this meter. Well, no, I want to give you an example of going backwards. So let's say the car traveled this meter in a time of 2 seconds. So if we know that this car is going 0.5 meters per second, and we have its momentum, we could also find the mass of this car too. So let's save that like that, and let's go back and figure that out. So let's say I want to know the mass of the car, and I don't know this, but I was given a time, and again, some of these things would have to be given to you. You can't figure out something with 5 variables unless you did you know, some kind of crazy backwards equation, which nobody's going to expect you guys to do at this juncture. But we could say that the mass of the car, there's a couple ways we could find it now. So we could just set the momentum of the car equal to its velocity, which we have, times its mass. So we could say, okay, these 40 kilogram meters per second is equal to the unknown mass of the car times this 1/2 meter per second, so 0.5 meters per second. And then we could divide 40 by the 0.5 meters per second and get the mass of the car. And the other thing we could do is, let me scroll down a little bit. There we go. So the other thing we could do, actually, and I'm going to scroll down a little bit more because I just realized in the video note then you guys have this wacky watermark on the bottom, so hopefully you can see everything. The other thing we could do is if we know the mass and speed over here, and we know the speed and no mass over here, we can set these two proportions equal. So I'm just showing you a different way to do this. So we could say this 0.5 meters per second, I'll write it in the right order for you, mass times this 0.5 meters per second is equal to 20 kilograms times 2 meters per second. And we could set it up this way. And you're going to get the same thing, or you should get the same thing both times, for the mass of the car too. So we can use our momentum formula going forward to find something that's missing from an overall equation, but we can also use it going backwards to kind of piecemeal out different information that we want to know. So this was just to kind of clarify some momentum stuff for a couple folks that had asked to have one more example. So hopefully that was helpful. And I will see you guys tomorrow. That's all I can think of. All right, bye.